Okay, in this video, we are going to keep talking about stepwise refinement. Um, so as I said in the last lecture, stepwise refinement is about writing some sketch and then as a pseudocode or as some English phrase, and then based on this blueprint, you elaborate some of the parts, okay? Last time the code was not really big. So what we did is basically lay out some variable structures and then you just filled out the detail in one shot. But if things gets larger, it gets harder to write the code in one shot, even with this blueprint. So idea of having blueprint is really good. So you keep refining it. But the problem is, like, once you, if you want to write the code in one shot, that's really hard, especially if it doesn't compile, if there's some error, or if there's some error, like you don't know where like is wrong. So the idea is while you write some piece of code, you keep checking whether what you just wrote is correct and then keep refining. So the idea is make sure like each iteration, the program, what you wrote so far is run correctly and it compiles well, okay? So you still want to check your small piece of code runs correctly. The other part, well, what does that mean? It's a really large code and there's some other parts you haven't written yet. So the idea is you put something really simple, like even dummy, so that it compiles. And that's still, as long as it's enough for testing your like code you just wrote. Okay, that's the idea. So in the lecture note, there is like pop.txt. So this is really kind of massive scale of the file that you have seen so far in this course. So this is basically contain, let's look at this file. So it has date of origin and there's years, seems like from 1910 to 2010. So that's 11 years. And then there's this United States. And then there's population, seems like there's 11 data points, one for each year. And then there's people per square mile, okay? And again, there's 11 data points. So that's basically aggregate data for the United States. And now from each state, you have population for each year, and then people per square mile, and then there's density rank, right? And then there's 11 data points, and then you move on to the next state. So I wrote this file. The idea is if you just keep density, that's basically people per square mile. It just looks for the file and finds out the best state that's very close to the density that you want. So basically Delaware is the state you should live. So if you check out the Delaware. Okay. So if you look at this square, we have to use the most recent data. So 460.8 is basically, that is. And then density is 1,000. Oh, Rhode Island is quite dense area. So Rhode Island, where is it? Rhode Island, yeah, here we go. And then, yeah, 1018.1. Okay, another one is Alaska. Alaska is really sparse. Alaska is 1.2, right? So that's basically what you need to do. So let's write it. Density. Let's see. IC210.h. I have to think about it. So what would be the bigger, How do you split this? So first one, well, you have to ask density. Okay. And then what? Read the file and for the right state. And then write the state and the corresponding density. Okay, that's what you need to do. Okay, so let's elaborate that. Okay, so ask for density from user, that's the easy part. Now puts density standard out. Okay, and then what? Density from user, read num from standard in. Good. So that's good. And then what? Step 2 is kind of complicated. So write the state. Oh, for that, probably you need to have test density, test state, say, and then double test density. Okay, and then we have to put S, test state, and then std out, and then std out with a white space, and then write num test density out, and that puts new line std out. So that's the easy part. At least you wrote something, and you can check whether it compiles or not. So GCC density. Okay, there's a warning. Best density is not initialized, but that's fine. We're gonna, because on the while, when you do the step 2, the value will be sent. Okay, so let's move on to the most important part, part 2. So read a file and look for the right states. Okay, let's elaborate more. So 2.1, we'll open the file. Oh, .txt. And then what? Read the file data points. And then what? 2.3, close the file. Okay. So how do you read a file? Well, you have to use stream a variable. So let's say the name of the variable is fin. So you have to open pop.txt with read mode. Okay. And then you have to close the file. So far, so good. Okay, so now you actually have to see into like the structure of the pop.txt file. So what these 4 lines are nearly not interesting because you want to find out the state, and this aggregate data is not relevant to our context. So, you know, you just, first one is what? Read off garbages. Okay, so you need to have some idea. So what is the good idea? One idea is this one. So basically read everything as a string. Read everything, read garbage strings until mile, until see a mile. And and then what? And then there's 11 data points. So, and then read 11 numbers. Okay. So let's do that. Yeah, let's just do this. Okay, and then let's move on to the next part. So 2.2, read state data points. But at least let's focus on this. So how do you do that? Well, you should have some string variable, let's say skip. Okay. And then let's initialize with a nothing, empty string. This is basically empty string. Yeah, maybe the better idea is use a string copy. String copy. Now after this, skip contains like empty string. That means there's nothing. The string is, the content of the string is really nothing there. Okay, so while you have to use while loop, right? Because you keep reading the strings. So read string into skip from where? From not from the terminal, but from the input file pop.txt. So that's why you have to put this string, not the standard in. Okay. You keep reading until what? You meet mile. So string equal skip is mile. If it is equal, then you have to stop. That means what? While skip is not equal to mile, this is not, right? So while skip is not mile, you keep reading strings into skip from the file fin. And then if skip is mile, you exit the loop. So now what do you have to do? You have to read 11 numbers. So do that 11 times. You can do read num, but I don't want to waste the variable. You can just use the same string. Okay, that's good. So then let's just add some check routine. Check. So if you read the header or like garbage right, the next string should be Alabama. So let's think about it. So I'll just create a state variable, and then I'll just read string into state from fn, and then I'll just print out outputs into the terminal so that Alabama will be printed out from terminal. So you wrote some of the piece here, and make sure you compile and then check whether what you wrote is really correct. So this is what I am doing. Okay, so let's compile. Density.c. Okay, that's fine. Lay that out. Density. Okay, Alabama. So far, like the best state or like density is weird, but that's fine because we haven't done anything. So that's not really something we need to worry about now. But like now the program prints out the Alabama, that's great. Okay, so now we can move on to read the state data points one by one. For now, just read one state. That is, which is Alabama. Okay, and when we are done, we're going to compile and test it. And then if it is correct, we'll just put this thing into the loop. That's basically the idea. So now, what is this thing? This, we read Alabama, and then what is important for us is this one, right? The density, and the rest of the stuff is not really important. So the idea is, again, read garbage strings until seeing mile, right? And now read, instead of 11 but 10 numbers, and read the density. That's what's important for us. Okay. So read state. I'll just copy this routine here because you have to read the state. Okay. Read the state, and then read garbage strings until mile. Read 10 numbers, read the density. And then there's some garbages. So to finish reading off, there's other garbages. That's density rank, so 2 more. So there's 13 garbage strings. So read 13 strings. Okay. So here, so let me do that. So read the string, and then I'm going to copy and paste this. Yeah, you have to initialize skip. Okay, always initialize skip, clean skip. Otherwise, things might not work well because of the small stuff, because of the previous slide reading. So read skip, initialize skip, and then until seeing mile, we would keep reading it, and then you read. And this is probably easier to read, right? So read the state, and then read garbages, and then read 10 numbers, and then read the density. Okay, so I should have some variable. Okay. So double density, read num, where? From the file. And then again, read some garbages. So I'll just copy and paste. And change this into 13. Okay, so to make sure this is written right, so I'll just fputs, and then I'll write num the density into standard out, the terminal. I'll just change this into this. Okay, so let's try to compile this. GCC density, kind of annoying. Okay, density, and Alabama 94.4. Let's see if it works fine. Alabama. Yeah, 94.4 is what we read. That's good. So now we can read more states. So you gotta put, what? While. And then this is basically, we'll see here, inside the loop of the body, body of the loop. Okay, so the question is, what do you put here? Like, when do you exit the loop? It's like reading the state data points one by one. And when do you end? One idea, let's just go to the end. One idea is, well, what's the last state? Last state is Puerto Rico. So when you see the Puerto Rico, so probably that's time to end. So that means what? If the state string equal, state is not Puerto Rico, right? While the state is not Puerto Rico, you keep doing that. So I need to pull out the state variable so that it can actually accessible in here. Okay, so then this is a problem, right? Why? Well, Puerto Rico is something to be in state, but read string is basically always containing one state. So sometimes you need to add some of the strings. So Puerto Rico will be one example, or Colombia. District Columbia is another example. Whatever it is, what should be the idea? Like, how do you take care of this? Well, the idea is, well, if you see, so read this and then keep reading it until you see what? Population. Okay, so then all the things before population should be added to the state. How do you add a state? Use a string cat function. But anyway, so here, I'm gonna create some temporary state, temporary C string. So what do? Let me just initialize temp with nothing so that like garbage is not really making things messy. So what if temp is not, while temp is not population, you keep reading it and then what? Add temp to the state when temp is not, if temp is not population. So if it is not population, you can add it. How do you add? So let's do that. If it's not population, how do you add? Use string cat function. So string cat function is string concatenation. So to where? This is the destination. Well, destination has to be the state. And first you have to add a space. Add this to state. That's how string cat function works. And then now, what you just read has to be added back to the state. Okay, so let me just read state. So what did you do? Read one string to state, and then read, keep reading string until seeing population, and then add the string to state. That's basically what we did. Okay, so far basically this will basically reading all the state data points. Okay, so let's compile. Remember, add some code and then compile and check. Okay. Oh, that's the problem. What is the problem? Okay, so keep reading it. And then state is not numbers, and that's fine. So probably you don't even print out anything. Yeah, what's the problem? Well, you haven't read temp, right? So you have to read a string into temp, right? Wrong pen. Otherwise, temp will be something weird, and that's why probably there's some problem. And temp is weird thing. Okay, so read string temp from where? From the file. Okay, and now it makes sense. So read a temp, and then if temp is not population, you add it to the temp. Okay, now let's compile again. It works. Okay, see, read string, with the problem. Yeah, there's a typo. Okay, let's correct that. See, so that's why it's really important to, write something and make sure it compiles and make sure it works fine. Okay, so do that. Okay, now we got it. Okay, so Puerto Rico, and then 188, 1000. So that's one. So it seems like the last one is kind of weird, but let's keep it that way. That's basically best state and best density. We haven't actually filled out. Okay, so now we only need to find the best density and then best state. So we created a best density and best state. So how do you find out the best state and best density? Well, given the density from the user, you have to match out the difference, right? So let's think about this. So how do you do that? Create, idea is, you have to create some variables, let's say difference. Okay, so the idea is create a minimal difference, really big. And then basically you compute the distance difference. What's the difference? Difference is basically what? The target density, like the density from the user, minus density in absolute form. So I'll just use FABS function. So that's basically returning the absolute value. So basically density minus density from user. Okay. To use FABS, you have to include age. Okay. Anyway. The note uses some other functions, some other routine. So basically, you don't need to use FABS. It's just if statement is probably, you know, take care of. Well, if statement also takes care of that, but I just like make sure that I just want to make the code simpler. I'll just call the absolute function. So the idea is what? If min diff, is it min diff? Min diff. If min diff is greater than diff, okay? So far, this state is containing the density that is, whose difference is the minimum. So that is closest to the density that the user inputted. So here, min diff should be now updated to diff, right? And then what do you have to update it to? What do you have to update? Well, you have to set the best state to the current state in the loop. So that means we have to copy best state into best current state into the best state. Also, you have to keep bookkeeping. You have to do the bookkeeping for the best density is the current density in this loop body. So that's the density. Right? So the idea is what? compute the difference of density if it's minimum so far. If that's the case, if so, take corresponding variable contents. So that's what happens. Okay, so you don't need to print out the checking variables. And then now best state and best density will contain the right value, and then at the end you will print out the best state and best density. Okay, let's try to compile it again. GCC. Oh, it compiles fine. Okay, density 500. That's good. Density 1, Alaska. Rhode Island 400.